Welcome back again to my channel. Today again I have came to you with a new topic of advanced Java, that is serialization. So before starting or going into the main part of the topic, I want to introduce myself. My name is Shom Shubhra Shaha. I work as an assistant professor in RMK College of Engineering and Technology in Chennai. So let's begin. So what is serialization? It is a process for converting a Java object into a byte stream. Now what is the purpose of this serialization? First of all, it saves object state permanently. Next, it helps in transferring object between JVMs. And third, it supports distributed applications. Now similarly, deserialization is also the process, but it is the reverse process of serialization where a byte stream is converted back to the original Java object. So this deserialization, the main motto behind this is to object persistence. Next is communication between applications. So to implement a serialization program, what is the main thing or what is the main requirement for this serialization process? First is that we have to import the library called java.io.serializable. So this process of serialization mainly falls under the interface of serializable. So in case of serializable interfaces, if suppose any object we don't want to convert it into the byte stream, for those object we have to add transient before writing that object. Third point is we are using over here Java output stream and a Java object input stream for this serialization process. The last thing is that, which is a very important thing, that is to control the version or control the byte process of serialization. A serial version ID is being provided to every object which is converted into the byte stream. So let's see what is the type of serialization. Mainly there are three types of serialization: default, custom and XML. Now the default serialization is where the JVM is automatically provided, and the default serialization is always used under the serializable interface. Similarly, in custom serialization, whoever develops it can control how the object can be serialized. Basically, in case of write and read object, this custom serialization is being used. The third part is the XML serialization. That means it is a form of external library. So it converts any human readable format into machine readable format. And next is that it is used in web communication and APIs. So it is very useful. So let's see what is this serializable interface. First of all, it is a marker interface. Why it is known as marker interface? Because it does not have any methods. And it also serves as a tag to tell JVM that objects of the class can be serialized. Second is that it falls under the java.io package, and object input stream and object output stream are also used along with that. The third point is that it enables object serialization. That is, whenever a serializable class is being implemented, the object is converted to byte stream for storage or transfer. The fourth point is it supports serialization, deserialization. That is, it can restore back the byte stream to its original state, which is a very plus point. So serializable interface, the fifth point is that it supports serialization of primitive fields, wrapper classes, collection and even nested object. Next point is it is used in distributed application like networking, and it can be used in storing several files, etc. So let's see the declaration of this serializable interface. First of all, in the very first line, you can see that we are importing the java.io.serializable package. After that, they have taken a class, student class, where the name is being given as serializable, and within that class they have passed two variables. One is id, which is in int, and another one is name, which will be in string. So let's see one example where we are writing an object. Now, very first we are importing that java.io package. Over here we have used asterisk, but you can use serializable also. After that, we are again creating a class student where it is implementing serializable. Through this class, we are passing two variables, that is id, whose data type is of integer, another one is name, whose data type is of string. After that, we are using this term this. This means the current object. This dot id is equals to the id. Similarly, this dot name is equals to the name. So after the declaration, we are using another class, that is serialized demo. Under that class, we are first passing the main function. Within the main function, the first is that try block is being started, where in the try block, the first, that is the variable student, which is denoted as S1, is creating an object new, where the student is passing two variables, 101, that is the id of the student, and name of the student, which is Rahul. After that, we are using this file output stream and storing the variable in FOS, which is creating an object new. Through the object new, again it is passing student.acr. Student.acr is a file name where the stream is being stored. After that, they are passing another object output stream and taken a variable OOS, which is equals to new, and again within the new object it is passing the FOS, that is the previous file output stream variable. After that, next point is that next line is that the object output stream is writing the object S1, that is the student one, with using the method dot write object. After that, it is closing oos.close using the method close, closing the object output stream and also closing the file output stream. After that, it is printing the object is serialized. But exception can happen, of course. That is why another block has been created over here, which is the catch block. And through the catch block, it is passing the exception E and printing if. That means if the file is not written, it will show the system.out.println E, that is, it will show the exception. So let's see another example, that is the reading object. Over here it's same. First we are importing the package import.java.io. After that we are creating a package, that is deserialized demo. Within that class, we are passing the main function. Under the main function, we are passing the try block. Within the try block, the first thing is that whatever we have written in the previous example, that is the writing object, we are reading that, okay. And now what we are doing, we are taking the file input stream and taking a variable FIS, which is equals to new is the object, where file input stream within the brackets student.acr. The student.acr file is already been created in the before example only. After that, we are creating another variable OIS, that is object input stream, and passing an object new, where they are passing that previous variable FIS over here. Then they are taking student s, a variable student s, which is equals to student OIS, that is student object input stream dot read object, that is whatever the data or Java uh, object that has been stored in the student variable, it's being read over here with the help of read object method. After that, it is closing the object input stream and file input stream. Then it is printing the ID and name. But if there is an exception is occurring, again for that purpose they are using this catch block where it is passing the exception. Now let's see what is this transient keyword. Now previously only in this lecture I have told you that whenever in a program, whenever which object we don't want to serialize, that object is the process is being blocked for that particular object by using the keyword transient. You can see over here in this example where they are already performing the process of serialization using the interface serializable. They have created a class account and implementing serializable. Within that they have passed one data, that is username. They are taking one variable username and passing the data type as string. Again they have taken another one password and passing that in string. But in this example, it is a example of a particular program where in this example the developer does not want to convert the password into byte stream. So that is why it has used the transient word before the string, that before the data type of the password, transient word. Once this word is being written into the program, then that the process in the process of serialization everything will be converted except this particular password. So this is the usefulness of this transient keyword. So another very useful thing for advanced Java or the serialization process is serial version UID. It is a unique ID. Basically it is being allotted for every serializable class which goes under the serialization process, and it also ensures whether whenever it is deserialized the same Java object is being gained through this process or not. It ensures, that is, yes. And then the last line you can see private static final long serial version UID equals to 1L. So this is the declaration when it is being this serial version UID is being allotted. This is the declaration how it is done. So let's see what are the advantages. First is object persistency, which I have already explained throughout the PPT. Next is easy object transfer, that is we can easily transfer any object through different JVMs. After that it supports this distributed system. Now there are certain limitations also in case of Java. First of all, it is not secure by default. So we have to mention this secure thing. So, and the performance is overhead, and the class structure of the class changes if there is any exception occurs during the execution. So these are the limitations of advanced Java or the serialization technique. Now we can use the serialization technique in remote method invocation, message application, caching, saving user session data, etc.